Picture two people standing in a field at night. One of them is holding a flashlight. The other one starts running as fast as a person can run, straight away from the light. Now the first person clicks the flashlight on, and the beam shoots out into the dark. Here is my question. How fast is that beam of light catching up to the runner? You already know the answer, or you think you do. If I throw a baseball at you at 90 miles an hour while you run away at 10, the ball only gains on you at 80. Subtract the speeds. Everybody knows that. So the light should be a little slower in catching the runner than in catching the person standing still. A little. Not much, but a little. It isn't. The light catches both of them at exactly the same speed. 186,000 miles every second, measured by the runner, measured by the stander, measured by anybody at all, no matter how they move. You can run toward the light. You can run away from it. You can ride the fastest rocket ever built. The beam always passes you at that one stubborn number. Always. That should bother you. It should bother you a lot, because it breaks the most obvious arithmetic in the world. And when something this simple refuses to behave, it usually means we have been holding a wrong idea so tightly that we never even noticed we were holding it. So let's go find it. Let's treat this like a crime scene, because something here is being murdered, and we need to figure out what. First, let's make sure the body is really dead. Maybe the experiment is sloppy. Maybe the light only seems to go the same speed. So here is what people actually did. Toward the end of the 1800s, there were these two fellows, Michelson and Morley, and they built one of the most careful machines anyone had ever made. The idea was beautifully simple. The Earth is flying around the sun very fast, tens of thousands of miles every hour. Light was thought to travel through some invisible stuff, an ocean filling all of space, and people called it the ether. So the Earth should be sailing through that ocean like a ship. And if you are on a ship, you can feel the wind of your own motion. A beam of light fired in the direction the Earth is moving should ride along differently than a beam fired sideways. The difference would be tiny. But their machine could see tiny. They ran the experiment, they turned the apparatus. They waited for the seasons to change so the Earth would be moving a different direction. They looked and they looked. Nothing. No wind. No difference. The light didn't care which way the Earth was going. It came out the same every single time. Think about how strange that is. It is as if you stuck your hand out the window of a speeding car and felt no breeze at all. Either the Earth is somehow standing perfectly still, which we know is nonsense because it is plainly going around the sun, or there is no ocean of ether for it to push through, or, and this is the ugly possibility nobody wanted, the speed of light is just fixed, full stop, and our nice subtraction arithmetic is wrong. People hated that last one. They twisted themselves into knots trying to save the old picture. Smart people, brilliant people. They said maybe objects squash a little when they move through the ether, just enough to hide the effect. They were patching, trying to keep the comfortable idea alive. And that is usually the sign in any investigation that you are protecting the wrong suspect. So let's stop protecting it. Let's take the strange thing seriously and just follow it, even if it leads somewhere uncomfortable. The clue is this. The speed of light is the same for everybody. Now I want you to hold on to something, because we are about to do the most important thinking in this whole talk, and it doesn't need any fancy mathematics. It needs only one honest idea about what speed even is. What is speed? Speed is a distance divided by a time. Miles per hour, feet per second. You take how far something went, and you divide by how long it took. That's all. There is nothing else in there. Distance and time. So watch what we just trapped ourselves into. We have a beam of light, and we are absolutely certain from experiment that its speed comes out the same for two people moving differently. But speed is distance divided by time. If two people moving differently get the same speed for the same beam, and speed is built only out of distance and time, then at least one of those two things, The distance or the time has to be different for those two people. It has to be. There is no other place for the difference to hide. That is the whole secret, right there. We just don't believe it yet. So let me build you a clock that forces you to believe it. I'm going to make the simplest clock in the universe. 2 mirrors, one on the floor, one on the ceiling, facing each other, and a single flash of light bouncing straight up and down between them. Up, down, up, down. Every time it completes a bounce, the clock ticks. That's it. A pulse of light is the pendulum. Because light always travels at that one fixed speed, this is actually the most reliable clock you could ever make. Now let me set up 2 of these clocks. One I keep here beside me, sitting still. The other one I put on a train, a very fast train, and I send it gliding past you. And I want you, standing on the platform, to watch the clock on the train as it goes by. Here is the part where you have to really see it in your mind. On the train, somebody riding along says the light just goes straight up and straight down, same as always, because for them the mirrors aren't going anywhere. Up, down, tick. Fine. But you on the platform see something different. While the light is traveling from the bottom mirror up to the top mirror, the whole train has moved forward. So by the time the light reaches the top mirror is not where it started. The light didn't go straight up from your point of view. It went up and forward, along a slanted path, like a diagonal. And then on the way back down, it slants the other way. From the platform, that pulse of light is tracing out a long zigzag, not a short up and down. Now look at what we have. A diagonal line is longer than a straight up and down line. You learned that as a child without knowing it. The slanted path across a room is longer than the path straight to the ceiling. So from the platform, the light on that train has to travel a longer distance for one single tick. And here is the trap closing. The light cannot go faster to cover that longer distance. It is forbidden. The speed of light is fixed. It is the same for the rider and for you. So if the light has farther to go and it is not allowed to speed up, then it must take more time to finish one tick. More time for one tick means the moving clock is ticking slower. Not because it's broken, not because the springs are cold or the gears are gummed up. It is ticking slower because that is the only way the universe can keep the speed of light the same for everybody. Time itself, on that train, is running slow, as seen from the platform. We have found the body. The thing being murdered all the way back in that field with the flashlight was the idea that time is one single thing ticking the same everywhere for everyone. That idea is dead. Time is local. Your time is yours. The train's time is the train's. Let me put a little flesh on how much it slows, without drowning you in symbols. The amount depends on how the moving speed compares to the speed of light. And here is the merciful part. At everyday speeds, the slanting of that light path is so unbelievably slight that the slowdown is almost nothing. When you walk across the room, when you drive your car, when a jet airplane screams across the sky, the diagonal is barely longer than the straight line. The time difference is there, but it is a tiny fraction of a tiny fraction. That is exactly why nobody noticed it for all of human history. We are slow. We crawl. Compared to light, the fastest rocket we have ever launched is practically standing still. But push the speed up, closer and closer to the speed of light, and that diagonal stretches out longer and longer, and the slowdown grows and grows. Get to 9/10 of light speed, and 1 second on the train stretches into more than 2 seconds for you watching. Get closer still, to 99%, and a few minutes on the train can be an hour on the platform. Right at the speed of light itself, the diagonal would be infinitely long, and the moving clock would, from outside, freeze. But nothing with mass can ever quite get there. We'll leave that locked door alone for today. By now, a sensible person is getting suspicious of me, and good you should be. You're thinking, this is a cute story about clocks made of light, but my wristwatch is made of gears, and my heart beats on its own schedule, and surely those don't care about some bouncing photon. Maybe only light clocks go slow. Maybe it's a trick of this one funny device. No, And this is one of the most beautiful arguments in all of physics. So let me lay it out for you carefully. Suppose your gear watch and your beating heart did keep the old normal time on the train, while only the light clock slowed down. Then you could simply look at both. You could sit on the train and watch the light clock falling behind your heartbeat, getting more and more out of step. And that disagreement would tell you, beyond any doubt, that you are the one who is moving. You'd have found a way to feel absolute motion from inside a sealed room, but you can't. That is a rule so deep it sits underneath everything. There is no experiment you can do inside a smoothly moving train with the shades pulled down that tells you whether you are moving or sitting still. You've felt this yourself. You're on a train in the station, and the train beside you slides backward, and for a second you can't tell if you're moving or they are. Steady motion feels exactly like rest. It always has. So if the light clock slows, every clock must slow with it, perfectly, in lockstep. Your heart, your watch, the vibrations of every atom in your body, the chemistry of your thoughts, all of it slows by precisely the same amount. Otherwise you'd catch the universe cheating, and the universe does not let you catch it. Everything slows together so seamlessly that, riding along, you notice absolutely nothing wrong. Your second feels like a perfectly ordinary second. It's only when someone else, moving differently, compares their clock to yours that the strangeness shows up. Let me stop and say plainly, because I can feel the doubt in the room. This is not a story. This is not a clever thought I cooked up to entertain you. We have measured it. Out there in nature, it is happening constantly, right over our heads. The sky is being rained on all the time by tiny pieces of broken atoms from outer space smashing into the top of our atmosphere. When they smash, they make little particles called muons. A muon is a heavy cousin of the particle that makes electricity. And a muon is a flickering, doomed little thing. It lives for about 2/millionths of a second and then it falls apart. That's its whole life. 2/millionths of a second. Now do the arithmetic the old, wrong way. A muon is born way up high, maybe 10 miles up. It comes screaming down toward the ground at very nearly the speed of light. But even at that ferocious speed, in 2/millionths of a second, before it falls apart, it should only be able to travel about 1/3 of a mile. It should die in the high air, miles and miles above our heads. Almost none of them should ever reach the ground. And yet, stand at the bottom of a mountain with a detector, and they come pouring through you by the thousands. They make it all the way down. Far more of them arrive than the old arithmetic could ever allow. Why? Because they are moving so fast that their time is running slow. From our point of view on the ground, that little internal clock counting down to the muon's death is ticking in slow motion. Its 2/millionths of a second, stretched by its enormous speed, becomes long enough for the trip. The muon gets to live longer, as we measure it, simply because it is moving fast. We don't have to imagine this. We count the muons. The numbers come out exactly as the slowing of time predicts. Nature did the experiment for us, billions of times a second, before anyone was clever enough to ask the question. And we have done it on purpose too. People took the finest clocks ever built, clocks so precise they can split a second into unimaginable slivers, and they put them on airplanes and flew them around the whole world. In 1971, that is exactly what happened. They flew the clocks around, then brought them home and laid them next to clocks that had stayed on the ground. The clocks that had flown were behind. By a tiny, tiny amount, billionths of a second, but behind. And behind by precisely the amount the slowing of time said they should be. The flying clocks had aged a hair less than the ones that stayed home. Time really did run slower for the things that moved. So it's real. The body is real, the murder is real, and we have caught the universe in the act. Now let me show you the twist that makes this whole case truly devious, the thing that turns it from strange into almost dizzying. Go back to my train. From the platform, you watch the train's clock run slow. Now climb aboard the train and look back out at me standing on the platform. What do you see? You see my clock running slow. Both of us. Each one of us sees the other's clock dragging behind. And your first instinct is to shout, that's a contradiction. Somebody has to actually be the slow one. But it is not a contradiction. And seeing why is the deepest part of the whole thing. It comes down to a word we never question, the word now. We imagine that there is one single now spread across the whole universe. One instant that everybody everywhere shares, like a great cosmic drumbeat. There isn't. When you are moving relative to me, your now and my now are tilted with respect to each other. The events you call simultaneous happening at the same instant are not the same events I call simultaneous. We don't even agree on which things are happening at the same time. And because we slice up time differently, each of us, looking across at the other, honestly finds the other one's clock running behind. Both are right. There is no single master clock in the sky to settle the argument, because we just buried the idea that such a clock could exist. People want to escape this with the famous puzzle of the twins. One twin stays home. The other flies off near the speed of light and comes back. If everything is so symmetric, they ask, why does the traveling twin come home younger? And he does come home younger, that part is true. The escape is this. The trip is not symmetric after all. The one who stays home just sits there. But the one who travels has to slow down, turn around, and come back. He feels it. He gets pressed into his seat when the rocket turns. That turning around is real, and it is something only the traveler experiences. It breaks the perfect mirror between them, and it is the traveler, the one who went out and came back, who ends up younger. He could leave for a long voyage and return to find his brother an old man, while he himself has barely aged. Not a fairy tale. A consequence, as solid as the muons falling through you right now. Let me gather up what we've done, because we came a long way from that field with the flashlight. We started with one stubborn fact that looked like a small annoyance. The speed of light won't change no matter how you chase it. We refuse to look away from it. We refuse to patch it over the way the clever people did with their squashing ether. And by following it honestly, with nothing more than the idea that speed is distance over time, we were forced, step by step, to give up something we never imagined we'd have to surrender. The universal clock. The single, steady now ticking for everyone. It's gone. There is no master clock. There is no one true time. Each thing carries its own time along with it, and how that time flows depends on how it moves. Sit still, and your clock runs as fast as a clock can run. Move, and you slip just a little into slow motion as the rest of the world measures you. The faster you go, the more you fall behind, until at the edge of light's own speed, time would nearly stop. I find I cannot quite put this thought down, and I don't think you will either. Every step you take, every time you so much as cross a room, you are nudging yourself a hair out of step with the people sitting still around you. Unimaginably small, yes, but not zero. Never zero. You and the chair you got up from are no longer keeping perfect time with each other, and you never will again. Motion is not free. You always pay for it in time. So here is what I'd like you to carry out of this room and turn over in your head tonight. If moving fast slows your clock, and there's no master clock anywhere to say who is really moving, then ask yourself this, honestly. When you sit perfectly still and feel time flowing past you at its steady, ordinary pace, what exactly do you think you are sitting still with respect to? Tell me what you decide.